This is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through true bearings. So bearings are a way to tell someone in which direction that you've gone. So let's look at what looks like the Cartesian plane. It's actually supposed to be like a compass, north, east, southwest. You already know that. If I said to you that, I've gone in a northeasterly direction, I could have gone like in this direction, or in that direction, or in that direction. Now, it might seem to you like they're all very similar, who cares? Well, if you're, say, in control of a plane, it is so important that you know, because if you go, say, in this direction, when you should go in this direction, you could end up at a city, thousands of kilometers apart, and there might not be a runway there. So then you'd be kind of screwed. So what we want in mathematics is we want a very definitive way to tell, have I gone in this direction or this direction or this direction? And that's where bearings come in. We assign each of those different directions with a different number. And that allows us to solve problems using trigonometry. So how do we assign that number? So this is what we do. We define the north axis, which is like the positive y-axis if it was a Cartesian plane. We start that at 0. And we always go in a clockwise direction, same direction as a clock. So east is at 90 degrees, south is 180, west is 270, and it goes all the way up to 360, which is back where we started at north, okay? Because a full circle has 360 degrees. So we look at the angle made with the north axis in a positive clockwise direction, and that gives us the bearing. So for example, if I wanted to go on, say, a bearing of 30 degrees, that would just be out here, and that angle there would be 30 degrees. Now, the way we write the bearing, usually it has 3 numbers, and we write degrees T for degrees true, because there is another type of bearing that we're not going through in this video. So it's 30 degrees true bearing. Now in yellow, I'll do, let's say I went 220 degrees true. So that is an angle of 220 degrees with the north axis. So that would be 90 plus that's 180. And then I need a little bit more to get to 220. So to be out here, so 220 minus 180 is 40 degrees. That angle there would be 40 degrees. So this is the direction of 220 degrees true. And we can tell, that that's going to be different from, say, if I went in this direction, you'd probably say that's also southwest, but this might be 225 degrees true. So we can make a distinction between them, even though they're both in like a southwesterly direction. So we're going to look at using these bearings to solve problems in trigonometry. So I'm going to show you an example now. Please pause and copy this down if you need. So a hiker walks on a bearing of 330 degrees true for 5 kilometers. How far north is she of her starting point? So what we do in these situations, again, if you're not given a diagram, you draw one. So always start by drawing up your compass. So we have north, east, southwest. So what does this have to do with trigonometry? Well, note north and west are at right angles, north and east are at right angles, and so on. We can turn this into a right-angled triangle. That's what we're going to try to do. So 330 degrees true for 5 kilometers. So she's going to go in which direction? It's going to be the northwest, because remember it goes 0, 90, 180, 270, and then 360 is back at north. So 330 is between 270 and 360, so it's going to be in this direction. So we draw a line in this direction. Now, because it's 330, this angle here will be 30, which of course means the angle made with the positive y-axis, the north axis, that will be 330 degrees. So she's gone in this direction, and she's gone for 5 kilometers. Now we can turn this into a right-angled triangle, because the east-west axis meets the north-south axis at right angles. So that will be a right-angled triangle. So 5 is actually the length of the hypotenuse. So if this angle here were 30, this angle here just inside the triangle must be 60. So I'm going to redraw this triangle so it's easy to see. What we have as a triangle like this angle is 60 degrees. This side, the hypotenuse, is 5 kilometers. And of course, we have north going this way, and we have south going this way, east is over here, west is there. So how far north is she of her starting point? So she started here, she ended up here. How far north is she of her starting point? So we're saying, what is this distance here? Well, that's the same as the distance here inside the triangle, because these two lines parallel. So we need to figure out this side here. That's how far north she is. This is how far north she's gone. This is how far west she's gone, because she went in a northwesterly direction. So we're going to figure out the value of x using trigonometry. We have a right-angled triangle, an angle, and an unknown side. So let's use trigonometry. So we have the hypotenuse. We want to find the opposite, so we use sine. So we have sine of angle equals opposite over hypotenuse. When the thing you want to find is on top, you multiply. So x is just 5 times sine 60. Again, you must make sure that your calculator is in degrees mode. So 5 times sine 60 gives us, to one decimal place, about 4.3. She's gone about 4.3 kilometers north. So the distance from here to here is the same as the distance from here to here, is 4.3 kilometers. Okay, how easy is that? We'll do one more example now where we use trigonometry to find the bearing. So I walk due south for 10 kilometers, that means like directly south, and then directly east for 12 kilometers, and I want to find the bearing from my starting point to my finish point. So again, no diagram, let's draw one. So I have a starting point. I go due south for 10 kilometers. Then I go due east for 12 kilometers. So south and east are at right angles. So I want to know the bearing from my starting point to my finish point. So we make it into a right angled triangle. So this is my starting point. So I can sort of put a compass here. Now I want to know the bearing from this point to this point. So it says from my starting point to the finish point. So that means the compass is here. I'm looking at the bearing from here to here. So to know the bearing, remember, it's the north axis and in a clockwise direction. I need to find this angle here that I've marked in red. Now that's outside the right angled triangle, but if I find this angle here, I can find the bearing easily because I can just subtract theta from 180, because 180 is the angle in a straight line. So I just need to find theta using trigonometry, then I can find the bearing. So I have a right angled triangle. I know the opposite and adjacent, so I use tan. Because it's an angle, I use tan inverse. So theta is tan inverse of opposite over adjacent. So again, make sure your calculator is in degrees mode. If I put that in my calculator, I get about 50.2 degrees. That's to one decimal place. So theta equals 50.2 degrees. Now, have I finished? Well, no, I found theta, but I didn't find what the bearing was. So if the angle in here is 50 degrees, then this angle out here will be 180 minus 50.2. So the bearing's 180 minus 50.2. So it's going to be about 129.8 degrees. And you write a T there because it's a true bearing. So that means if I go 10 kilometers south and 12 kilometers east, the bearing from where I started to where I ended up is 129.8 degrees true. All right, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.